In this video, we are going to learn static structural analysis of pressure vessel in ANSYS Workbench. So here we have a pressure vessel which is made of stainless steel, and the legs are made of structural steel. And this vessel is consist of three parts. One is this hemisphere, and the second hemisphere, and the cylinder body that is welded with each other. And on this pressure vessel, the internal pressure is acting of 0.4 megapascal, and the bottom ends are fixed, and we are going to calculate the equivalent stresses over the model. So let's start the analysis. We are going to take static structural system, and now we are going to define first engineering data, where we need stainless steel material. For that, we'll go to material library, and here I'm going to take general material. In the general material, we are going to take stainless steel material. We'll click on the plus icon to assign that material to the library. Now we'll close. Now we are going to import our model. So right click here and we'll go to import geometry, browse, and we are going to take the pressure vessel here and open the part. Now to view the geometry, we will double click on the geometry to open the model. So here that space clamp window is open where we can see our model. This is a cylindrical body we have. So this part is welded with each other. Okay. Now we're going to take into mechanical window. So we exit from the space clamp window. To enter the mechanical window, we'll double click on the model. So here our model is loaded. We can see in the screen. Now we will define the geometry condition. So first of all, we are going to define the material. So the cylinder and the hemisphere part, we have stainless steel material. We'll just assign the material to stainless steel. Now the legs will be made of structural steel. Now we are going to define the connection for the part. So as this body is welded body, so we need to maintain the bonded type contact between all the contacts. Now before defining contact, I'm going to rename on the basis of definition. Right click and say rename based on definition. So we can see here that initially the contact type that is applied between each of the part, that is bonded contact. So there's no need to change the contact type. Now we're going to define the mesh. So in the mesh, let me define element size of 50 mm, and we'll generate a mesh. Okay, like that we have just specified the mesh. Now we're going to define the boundary condition over the part. So in the boundary condition, the bottom legs are fixed. We'll define that will be fixed. Take a fixed support. Select all that 4 faces and apply. Now we have internal pressure of 0.4 megapascal that is acting internally on this body. For that case, we can explode this assembly and we can apply the internal pressure. For that, we in display tab will have one option explode tab. In this, we can use the explode method. Now here we can specify that pressure that is acting internally. So we'll select all the faces, apply 0.4 megapascal. Now we'll reset back. Now we are going to define what we need in the solution. We'll just calculate here. I want to see the total deformation over the model, and I want to calculate the stress solve. Okay, so we can see the results, total deformation and that von Mises stresses. Let's view in the form of undeformed model, okay, where we can see the stresses over the model. You can also play the animation. You can see how it will be stressed, and we can see the total deformation that is happening over the model, and where the maximum and minimum deformation is coming. That also we will take that props. So we'll stop the animation and we can see where it will have maximum deformation and minimum deformation, and we can check where we have the most stress over this part body and minimum stress over the body.